The life and legacy of Roger Bacon, the medieval polymath ahead of his time. Esteemed colleagues and scholars, today we delve into the profound life and enduring legacy of Roger Bacon, also known by the scholastic accolade Dr. Mirabilis. Born in the early 13th century, Bacon was a quintessential polymath, a philosopher, scientist, theologian, and Franciscan friar who remarkably intertwined empirical methodology with theological inquiry. His work not only challenged the intellectual paradigms of medieval Europe, but also laid foundational stones for the modern scientific method. In this discourse, we shall explore Bacon's contributions with rigorous analysis, emphasizing his advanced understanding and the intricate details that underscore his genius. Roger Bacon was born around 1219 or 1220 in Ilchester, Somerset, England. His exact birth date remains a topic of scholarly debate, with proposed years ranging from 1210 to 1220, primarily due to the cryptic nature of medieval records. Bacon hailed from a well-off family, which provided him with the resources to pursue extensive education, a privilege in medieval England. He commenced his studies at Oxford University, an institution that was, during his time, a burgeoning center of intellectual activity. While at Oxford, Bacon was profoundly influenced by the works of Robert Grosseteste, the Bishop of Lincoln, whose emphasis on empirical observation and mathematics resonated with Bacon's intellectual inclinations. Additionally, the teachings of William of Sherwood in logic and linguistics significantly shaped Bacon's early scholarly pursuits. Bacon immersed himself in the trivium and quadrivium, mastering the classical studies of grammar, rhetoric, logic, arithmetic, geometry, music, and astronomy. This comprehensive education equipped him with a versatile foundation, enabling his later interdisciplinary contributions. His early exposure to Aristotelian philosophy, coupled with his critical approach to traditional scholasticism, set the stage for his future endeavors that would challenge and expand the boundaries of medieval thought. Following his formative years at Oxford, Bacon accepted an invitation to lecture at the University of Paris around 1237. At Paris, then the epicenter of European intellectual life, he lectured on a diverse array of subjects, including Aristotelian logic, Latin grammar, arithmetic, geometry, and the mathematical aspects of astronomy and music, a testament to his polymathic expertise. During his tenure, Bacon interacted with eminent scholars such as Albertus Magnus and possibly Peter of Spain, who would later ascend to the papacy as Pope John XCIII. These interactions exposed him to various intellectual currents, including the works of Islamic scholars and the integration of Aristotelian philosophy with Christian theology. Bacon's pedagogical approach was revolutionary. He emphasized direct engagement with original texts and empirical observation, diverging from the prevailing reliance on secondary commentaries. By 1247, however, he grew disillusioned with the limitations of traditional scholasticism and returned to England. Back at Oxford, he devoted himself to private scholarship, delving deeper into experimental studies and esoteric fields that were often marginalized by mainstream academia. His withdrawal from formal academic roles signified a shift towards independent inquiry, allowing him to circumvent institutional constraints and pursue his innovative ideas unencumbered. In 1256 or 1257, Bacon joined the Franciscan order, embracing a life of religious devotion alongside his scholarly activities. The Franciscans, with their commitment to poverty and education, provided a conducive environment for Bacon's pursuits. However, the order imposed strict regulations that restricted the publication of works without approval, creating tensions between Bacon's desire for intellectual freedom and the constraints of his monastic life. Despite these restrictions, Bacon endeavored to continue his research discreetly. His relationship with Pope Clement IV proved instrumental during this period. Recognizing Bacon's extraordinary intellect, Clement IV requested comprehensive writings on Bacon's studies. This papal patronage allowed Bacon to bypass the usual prohibitions, albeit under a veil of secrecy. Under the Pope's directive, Bacon produced several significant texts, including his Opus Majus, which he sent to the Pope in 1267. The support from Clement IV was crucial, providing not only moral encouragement but also the necessary resources to undertake his extensive projects. Nevertheless, The death of Clement IV in 1268 marked the end of this period of relative openness, and Bacon faced increasing scrutiny from his order. The latter part of Bacon's life as a friar was characterized by conflicts with ecclesiastical authorities, culminating in his censure and possible imprisonment. Opus Majus. The Opus Majus, completed in 1267, stands as Bacon's magnum opus, a comprehensive treatise that embodies his expansive vision for the reformation of knowledge. This monumental work, exceeding 500,000 words, was structured into 7 parts. Cause of error, an analysis of the 4 general causes of human ignorance: authority, habit, popular prejudice, and the concealment of one's own ignorance behind apparent wisdom. Philosophy's relation to theology, a discourse on how philosophy underpins theological understanding, advocating for a harmonious relationship between reason and faith. Usefulness of grammar, emphasizing the critical role of linguistics in interpreting sacred texts and philosophical works accurately. Mathematics and physics, arguing for the centrality of mathematics as the foundation of scientific inquiry and physical understanding. Perspective, optics, an in-depth study of optics, covering theories of light, vision, and the mechanics of perception. Experimental science, highlighting the importance of empirical methods and direct observation in acquiring knowledge. Moral philosophy, discussing ethical considerations and the application of knowledge for the betterment of society. The Opus Majus was revolutionary in its insistence on empirical verification and the use of mathematics as a universal language of science. Bacon drew extensively from Islamic scholars, such as Al-Hazan, and classical sources, integrating their insights into a cohesive framework. His work advocated for a curriculum that emphasized the study of nature through direct experience, laying early groundwork for the methodological approaches that would later define modern science. Recognizing the risk of his primary work being lost or misunderstood, Bacon composed the Opus Minus and Opus Tertium as supplementary texts. The Opus Minus served as an abstract of the Opus Majus, encapsulating its key arguments and findings. The Opus Tertium provided additional insights and addressed potential objections, ensuring that his core messages were preserved. Together, these texts constituted a formidable body of work that challenged the intellectual status quo of the 13th century. Bacon's call for educational reform and the adoption of empirical methods further elaborated on his critiques of contemporary scholars who relied heavily on tradition and authority rather than exploration and experimentation. Optics. Bacon's contributions to optics were groundbreaking. Drawing upon the earlier works of Al-Hazan and Ptolemy, he conducted extensive studies on the nature of light, vision, and perspective. He explored the anatomy of the eye, the physiology of sight, and the laws governing the reflection and refraction of light. In his treatises, Bacon delved into the mathematical principles underlying optical phenomena, such as the angles of incidence and refraction. He postulated that light travels in straight lines and investigated the properties of lenses and mirrors. His analyses anticipated the later developments in geometric optics and influenced subsequent scholars like Johannes Kepler. Bacon's insistence on experimentation led him to construct devices to test his theories, making significant strides in understanding magnification and the behavior of light, a precursor to the development of eyeglasses and telescopes in later centuries. Gunpowder. One of Bacon's most intriguing contributions was his record of the formula for gunpowder, the first in Europe. In his writings, he alluded to a mixture of ingredients that, when combined, produced explosive effects. While gunpowder originated in China, Bacon's documentation marked its introduction to European knowledge. He described the composition involving saltpeter, potassium nitrate, charcoal, and sulfur, noting its potential for both destruction and propulsion. Bacon foresaw its military applications, hinting at the possibility of firearms and cannons, which would later revolutionize warfare. His awareness of gunpowder's properties underscores the transmission of knowledge along the Silk Road and highlights Bacon's role in synthesizing and disseminating technological advancements across cultures. Calendrical reform. Bacon critically evaluated the Julian calendar, identifying inaccuracies in its calculation of the solar year. He observed that the calendar was misaligned with astronomical events by approximately 1 day every 125 years, leading to significant discrepancies over centuries. Proposing a correction, Bacon suggested adjustments to realign the calendar with equinoxes and solstices. His recommendations included omitting a day at set intervals to rectify the cumulative error, a concept that prefigured the Gregorian calendar reform implemented in 1582. Bacon's work on calendrical reform demonstrated his application of astronomical observations to practical problems, reflecting his holistic approach to science, wherein theoretical knowledge was harnessed to address real-world issues. Bacon's engagement with alchemy was both theoretical and experimental. He explored the transmutation of metals, the quest for the philosopher's stone, and the potential for prolonging life, common pursuits among alchemists of his time. However, Bacon approached alchemy with a critical eye, emphasizing meticulous experimentation and the importance of empirical evidence. In linguistics, Bacon was ahead of his contemporaries in advocating for the study of multiple languages, including Greek, Hebrew, and Arabic. He recognized that many classical and scientific texts were either mistranslated or misinterpreted due to linguistic barriers. Bacon proposed the concept of a universal grammar, a set of underlying principles common to all languages. This idea anticipated later developments in the field of linguistics and underscored the interconnectedness of language, thought, and knowledge. His emphasis on linguistic proficiency aimed to enhance theological scholarship by ensuring accurate interpretation of sacred texts. Bacon argued that understanding the original languages of Scripture was essential for true comprehension, a stance that prefigured the humanist scholars of the Renaissance. Legacy and influence. Roger Bacon's advocacy for empirical methods and mathematical reasoning laid critical groundwork for the development of modern science. He challenged the reliance on authoritative texts without verification, urging scholars to observe, experiment, and question. This empirical approach influenced later thinkers, such as Francis Bacon, no relation, who formalized the scientific method in the 17th century. Bacon's efforts to reform the medieval university curriculum also led to the inclusion of new subjects like optics, altering the educational landscape. His interdisciplinary pursuits exemplified the value of integrating diverse fields of study, a principle that remains foundational in contemporary academia. Despite his scientific endeavors, Bacon's reputation became entwined with myths and legends. Stories of his brazen head, a mechanical or magical device purportedly capable of answering any question, cast him as a sorcerer or wizard in popular folklore. These tales, while fictional, reflect the awe and misunderstanding that often surrounded advanced knowledge in medieval times. Such legends have permeated literature and culture, influencing works like Robert Greene's play The Honorable History of Friar Bacon and Friar Bongay. These narratives illustrate the tension between innovation and superstition, highlighting the challenges faced by scholars who ventured beyond accepted norms. Contemporary scholarship has re-evaluated Bacon's contributions, recognizing him not merely as a precursor to modern science, but as a product of his medieval context. His work embodies the intricate blending of theology, philosophy, and empirical investigation characteristic of the time. Bacon is acknowledged for his methodological rigor and for pushing the boundaries of knowledge within the framework of medieval scholasticism. His insistence on the compatibility of faith and reason offers valuable insights into the intellectual milieu of the 13th century and provides a nuanced understanding of the evolution of scientific thought. In summation, Roger Bacon emerges as a towering figure whose intellectual pursuits transcended the limitations of his era. His unwavering commitment to empirical research, coupled with his profound theological insights, forged a legacy that resonates through the centuries. Bacon's life exemplifies the relentless quest for knowledge and the courage to challenge established paradigms. As we reflect on his contributions, we recognize the foundational role he played in shaping methodologies that underpin modern science and philosophy. Roger Bacon's work invites us to consider the enduring value of curiosity, critical thinking, and the seamless integration of diverse disciplines in the pursuit of understanding.